But I'm here with you. Okay, so here's regular expression. What's a regular expression? What's a regular expression? Okay, it's a series of characters that denotes a pattern. Denotes one or more, zero or more, one or more sort of possible sequences of characters, right? It's up a sequence of characters, so it could be, something like, dot star, right? What does that indicate? What does dot star mean? Zero or more any character. Does that match any string? Matches all strings, including the empty string. Does it match the empty string? Yeah. Does it match A? Yeah. Does it match A? Yeah. Does it match A? Yeah. Does it match B? Yeah. Does it match AB? Yeah. And it matches all of them, right? It's a sequence of characters. But it matches, it's a pattern. It indicates some pattern, and the pattern matches all those. Or it could be cat or dog or something. What does that match? Okay, it matches cat. It matches dog. What does it match cat? Yes, it actually does match cat. We haven't constrained it so the cat has to be all it matches. So it matches capture, in fact. Dog matches, well spoken. I'm trying to think of something that ends with dog, or that has dog within it, but certainly there's dogma. Maybe there's a dogma, the opposite dogma, or something like that. And it doesn't match that? Yeah, it matches that. So it matches certain types of things, and certainly also most emphatically matches our feline, canine, and friends. But these are regular expressions, and regular expressions are extremely useful. They're built up out of characters and operators, schemes that indicate. What's an operator in this case? What operators do I have? Yeah, this sort of dollar sign is an operator. In fact, you can think of sort of dot as kind of a degenerate case, kind of an operator. But what are the operators in this case? Yeah, the parentheses and this sort of or operator. So it's sort of a calculus of these things, just like with math, we have sort of math with real numbers, we have A plus B or something like this. Here we have these operators instead of plus in the meaning, numeric addition of real numbers. Here, plus means something different. Suppose I did have a dot plus. What does that mean? One or more of any character, right? So we have operators operate on these sort of strings to mean certain things. Now, grep is just one of thousands, maybe tens of thousands, probably tens of thousands, maybe more by this point, programs that interpret regular code. They are writ large in daily experiences in the life of programmers and the life of IT people worldwide. Regular expressions are some of the most useful things you can find. Grep happens to be one I use for illustration. If you were to download this, or if you were to use Emacs, or you were to fire up VI, or you were to use Perl, or you were to use awk or sed, or all these have regular expressions that denote a feature within them. And they're so useful that they've been built into many, many libraries for C or C++ or Java, etc. And many languages build them into the language so that you can really easily use them to kind of recognize characters. Imagine that you have a config file and you want to read what's in the config file, you use regular expression. Okay? So, Correct is one program that allows you to use regular expression. And for the most part, we kind of look for lines which match some regular expressions. We ask it to show the lines which match the regular expression. But there's many modes for it. We can output lines which don't match regular expression. What's the option to grep that allows us to do that? Def, yeah. We can, for example, tell it to be case insensitive, so to not pay attention to case. We can tell it to use extended regular expressions. And generally you want to use that because extended regular expressions are really useful, and if you don't have them, it's just often a pain. So you generally want extended regular expressions. You have grep line is E, or you use egrep. Okay? Or you may want to count the number of lines which match this expression. And you know, there's actually a bunch of different grep-related things. So there's grep, and there's egrep, and there's fgrep, etc. These are all sort of variants, and I don't expect you to know all the details, although I do expect you to know that you need egrep or grep minus E for you know, to have full generality with the regular expressions. Okay, so grep is very, very useful. I actually have really mixed feelings teaching you regular expressions purely with grep, because some of their absolutely just amazing uses are when you use them for substitution. You say replace this by this, because that's where the pattern matching and use of the match syntax, like match 1, match 2, becomes really useful. You say, you know, match this thing by, you know, replace this one by this other thing, which took information from the first match. And it's just beautiful. I'm hoping I still may share that beauty with you at some point. Okay, so we talked about some of the operators here. We talked about the first three for sure. We alluded to this one here, which is not a pipe. It's this vertical bar indicating match this or this other thing, match this thing or this other thing. What does this thing do here? Yeah, it forces it to be at the beginning of the line. How about this character here? End of line. How about when you put something in between these square brackets? Any of the things in there. Any of the things that are in there. So if I say match, for example, A, B, and, you know, followed by, well, A, B, star. What am I really saying? Yeah, any sequence composed of A's or B's. So does it match an empty sequence? Yes. Yes, because it's star, so it's 0 or more of these. Does it match A? Does it match B? Does it match AA? Does it match AB? Does it match BA? Yes, yes, okay. All these. So that's good. So this matches any one of these guys, right? Any one of them, for each sort of iteration of this, okay? Now let's suppose this were AB plus. It would match all of these as well, but it wouldn't match the empty string, right? Okay, so very important to realize it doesn't match. It doesn't have to be the same one every time for this plus. It's not like this only matches A or B, 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 or something. It could go A, B, A, B, A, B, or A, A, B, etc. So, so we have this operator. Now, one thing I can't remember if I don't think I required it in a lab, but something that's really useful for you to know about is there is an exception to this, which is kind of confusing, okay? And I'm just going to mention it to you, even if it's not on the test or whatever. It's a really good thing to know about. And who knows, maybe you're a final exam. So you can have a very common pattern you see is this with a caret character in front of it. And it will say, for example, you may say A or B here. What does that mean? Can anyone tell me? No? Yeah, it means match something that's not A or B. It's not either A and it's not B. And you can do, for example, plus. So this would be matching a character that's neither A nor B. Okay? So, in other words, it's kind of the opposite of this. So this fact that we kind of put a caret, thank you. Yeah, a caret character in front of it indicates it's kind of the not of this thing. It's sort of, it's some character, but it's not one of these guys in here. Okay? This is just a very common pattern, so you should be aware of it. And occasionally, you know, I might see fit to make use of it, but it's very common. So you would say, for example, you know, I want to match a bunch of things, but then I want to look for something that doesn't have a comma in it, and then it's matched by a comma after it, for example, and I want to remember those things. Because later, I just want to replace this by, you know, this, whatever was in here, something like that. And you may have this, you know, dollar signs of matching things that are separated by commas, where these things do not have commas in them, something like that. Okay, so that's sort of a caret, this sort of thing. Now this curly brackets, like the parentheses, we call them. Parentheses. So I have cat or dog, for example. This is matching, you know, either subject or cat, subject to case dog. But what else is it doing besides that? What else besides sort of grouping these things? Yeah, it's remembering this so I can put a slap later to remember it. So I can later refer to whatever this was. If this is the first parentheses here in the line, I can refer to it as \1. And maybe there's more than one in that line. Maybe there's several of these. So maybe, you know, I have cat or dog, and then I have after that I have some sequence of characters which, it's not comma or colon, and then I have, you know, there has to be one or more of those, and then I have, you know, foo or bar. So, or I'll have iguana or tell me another cat, porcupine. Well, okay, so here, \1 would refer to these guys, \2 would refer to these guys. But what gets really interesting is, so I could have that, and if I'm going to do a regular expression, replace, this is really nifty, because then I could say, replace this whole thing with only \1, you know, I could have it separated by exclamation, or, you know, by a tab character, \2, and it would actually replace this thing by this. And that's outside of graph, so I'm not asking you to know, but it's just nifty. But the other place we could use this, the other reason we like to remember these things, besides replacing one by the others, we could, for example, say here \1. Now, what would this recognize?
Whichever was matched from the first set.
Yeah, that's defined it again. So we're seeing cat here, and then we have a bunch of characters which are neither colon or comma, and then we see again cat. Or it could be a dog here, and then we want characters neither comma nor colon, and then we match dog again here. So whichever dog is matched here, we see again. So that's besides just kind of grouping things, you have to realize that these parentheses remember things. Like What sort of animal? An elephant. Thank you. And I admired the elephantine memory of whoever made that utterance. Okay, so then we talk some about my thought would be to leave regular expressions right now, so we can move on to other topics covered. Does anyone have questions on regular expressions? Things you'd like me to do in front of you? Questions on the syntax? Questions on how grep processes them? Any questions? Yeah.
With the parentheses, if
Yeah.
you wanted it exclusive, so it was a word that had cat and dog on it, there'd be away from that. Or is that too complicated for
Right. So if I want it to be cat, okay, but if I want it to be cat but not dog, that's, I mean, if it's cat, it is not dog. But there is a need that comes up that sometimes you want it to kind of match this as long as there's no dog later in here, or something like that. And that's not something that regular expressions can directly allow you to do. What you could do is kind of later filter out lines. So what I do is I have a pipeline. I match the things that have cat in there, and then a later stage of the pipeline I filter out the ones that have the dog in it. And thereby I get pure feline, purely feline contents. Does that make sense? But it wouldn't be part of regular expression. It's, I'm going to make a statement that may seem puzzling to you, but I just want to emphasize things. So regular expressions are extremely powerful, but they're strictly less powerful than some other things we can do. So it turns out that in some of your other classes, you may have a chance to recognize that regular expressions, they're incredibly valuable. On a practical level, they're both nifty and sort of day-to-day useful. They're real workhorses. They get a lot of work done. We use them as part of bread and butter programming. But they're strictly less powerful than, for example, a grammar would be, or self-push down function. And so the sort of thing that you're talking about, there's certain things that you could ask me, like, I'll tell you another one that you cannot do with regular expression. You can give me the most sophisticated regular expression thing in the world, that's all sorts of neat syntax. You're not going to be able to do this. You can't recognize expressions which have matching numbers of parentheses, open parentheses and close parentheses. They have either 1, 2, or 3. You can map each of those. I can write a regular expression that recognizes things that have exactly 1 open and 1 closed parentheses, or exactly 2 open and 2 closed. So separated by any number of things, or 3. But I can't write a regular expression that gives me any number of those. Okay? And so there's going to be certain things that you'll ask, can you do this in regular expression? The answer is no. But there's other languages which you have the option of learning in computer science by which you can do these things. And if you're really interested in learning these things, you can go and find tools where you can very readily recognize the sort of thing you may be talking about, the sort of thing with those open and closed things, for example. And it turns out, by the way, something that allows us to recognize those open and closed parentheses, we can do that, but still have a language that's strictly less powerful than Java, or than Lisp, or than Scala, or than Python, or than Perl. All those languages are interchangeable in the sense that anything we can do with one, we can do with the other, period. Okay? So they're all, in some sense, interchangeable. They're all equally powerful. Anything I can do in Python, I can do in Fortran. That may seem weird, it may seem like perverse, but I can do it. I can do it in assembly language. And the point is you have these classes of hierarchies of languages, and regular expressions is like the simplest. It's really great and powerful, but it's like the weakest of them. And you can go up several levels, and then you're at the top level. And there's nothing more powerful than a universal term or what we can do in these sort of languages. There's nothing that sort of transcends even that in terms of what's computationally more powerful. So it's kind of a nifty hierarchy. I did realize I forgot some operators, ladies and gentlemen. And they're not so predictable that I always forget the same thing. So there's an operator where we'll say, for example, I want to match A, and I have 2, 3. What does that mean? 2 or 3 times repetition of this, right? How if I had A, B in these brackets, what does that mean? 2 or 3 times. And it's not always the same one of them, right? This is the important thing. It could be A, B, for example, matches. It could be A, sure. It could be A, B, B, right? It could be B, B, B. It could be A, right? So any one of these 2 times, it could be B, B, just to complete the sequence. Oh, I'm not having completed all the result. So that means that many times. Ladies and gentlemen, if I left out this, what does it mean? 2 or more. How do I left out this? 3 or fewer? No? That's good. Now, ladies and gentlemen, how if I had cat What if I had this? What will that match? Okay. It'll actually match words ending in cat. Ending in cat. This is sort of the anchor. Words ending in cat. So if I had a line which had cat. Cat, dog. Would this match it? Yeah? Would it match it? Okay. It would match it because it's at the end of that. Would it match? Would it match this? No. Would it match this? Yes. That's right. So this is matching things where this string is at the end of the word. The sort of obverse of this is this guy, in which case it'll match things that begin with cat. Words that begin with cat. So I can sell something before it as long as the word has some spaces or something that's not alphanumerics and is not an under bar. I think it's a little bit weird. It's kind of geared for firm errors, and basically it allows you to recognize so-called identifiers, things to be like individual functions or whatever. But there's always sort of something here that's not alphanumeric and not an underbar. It counts as sort of the beginning of the word. So we'll recognize that, whereas it won't recognize, for example, that. Okay, so that's good. How is that different from this? Sorry? This is the beginning of the line. Hold on, this is called an anchor. It's fair. And it sort of forces that to be at the beginning of a line. Okay? And similarly, there can be something that you could force it. So what is this going to match? It's going to match what? All lines that start in, all lines that consist of cat. Yes?
With the curly braces, do you see or is it 2, 2, 3? So if you have, say, 1, 5, it match 1, 2, 3, 4, and 5 instances, or would it just be 1 or 5?
It's a great question. If you had 1, 5, it would match 1, it would match 2, it would match 3. It's between a min and a max, okay? Where it includes the min, it's inclusive. It includes the minimum and includes the max. Okay? So that's a good question. Any other questions on regular expression? Okay. Time is running on here, so we're going to be going, but it's the time has been well spent. Okay.